A non-monochromatic light is used in an experiment on photoelectric effect. The stopping potential is related to the mean wavelength, longest wavelength, shortest wavelength, not related to the wavelength. So first of all, what is the meaning of non-monochromatic light? What is the monochromatic light? Means a light having a single wavelength, like the laser one. Laser light is a monochromatic light. And non-monochromatic light means several wavelengths are mixed up. So, as we know, in case of photoelectric effect, suppose nu is the frequency of the light, then energy of the single photon is given by h nu. And this particular energy of the photon is used up in two ways. One goes for work function, which is the energy required for the ejection of the electron from the metal surface. This is known as the work function of the material. This is work function of material. And then plus remaining amount of energy, if any, goes to kinetic energy of the electron. And there is a potential difference applied between the emitting plate, the emitter material, and in front there is a metal plate, and there is a potential difference between the two. And this potential difference can be made positive and as well as negative. Means this particular plate may attract the electron emitted by this particular photosensitive material and may repel also by negative polarity, because here this thing can be adjusted. So let us apply a negative voltage in such a way that no electron is able to reach this plate, because we have to apply a negative voltage in such a way that no electron is able to reach this particular plate. Then what should be the situation? The kinetic energy of the electron must be used up in this potential difference. Say Vc is the cutoff voltage, the stopping potential. Another name for the stopping potential is also the cut-off voltage. Cut-off voltage is another name for the stopping potential. So here you can see half mv square is EVC. So cut-off potential, basically Vc, is equal to h nu minus w. That means Vc is equal to h. In place of nu we can write c by lambda. So it becomes E lambda minus w upon E. So here you can see that a stopping voltage Vc is almost inversely proportional to the wavelength from here. Not directly, means it is approximately inversely proportional to the wavelength, because this factor is also there. What I mean to say that more is the lambda, cutoff voltage will be the less. So stopping potential is related to the shortest wavelength. Why? Because the shortest wavelength will require, for the shortest wavelength Vc will be maximum, because we have to stop all the electrons, so we have to stop the maximum energy electrons, which are basically shortest wavelength. So C answer has to be the correct answer to this question.